Okay, so I'm going to look at nucleophilic addition. We'll do a generic reaction in the first instance, and what we'll do is we'll take a carbonyl compound, which is going to have the delta positive center, and obviously a carbonyl having a delta minus center. We'll use an aldehyde in the first instance, and we'll go just for the simple ethanol situation, and we'll react it, as I say, we'll just do a generic scheme in the first instance and do a specific example in the next one. But we'll take a nucleophile, which is going to have a negative charge and a lone pair of electrons. And what we've done in all the previous examples of organic mechanisms is identify where the electrons are and where the electrons aren't. So we obviously know that the lone pair of electrons is going to have a high electron density because of the lone pair, and the delta positive here, caused by the electronegativity of the oxygen, is going to remove electron charge density from the carbon center and mean that that is now electron deficient. So what's then going to happen is that the electrons from the nucleophile are going to move towards the carbonyl. That's going to donate 2 electrons to that central carbon, giving carbon, for that instant in time, 10 electrons around its center, 2 electrons in the methyl bond there, 2 electrons in the hydrogen situation there, and then obviously the 4 within the double bond of the carbonyl, which means that one of the pair of electrons has to be switched to the oxygen. And what that then does is opens up the carbonyl bond. That creates the bond to the nucleophile, which is the one that we're wanting to create. The methyl group is still there, the hydrogen is still there, but then the oxygen has now picked up the negative charge which the nucleophile had originally, plus it then has its own electron pair there. And so what we then have to do is essentially complete the reaction. Now this one's an interesting reaction in that there's sometimes not necessarily a reagent that does this, but this picks up via the lone pair, it picks up a proton. Now where that proton comes from can sometimes be fairly generic. It can come from an acidic reagent, or it can just come, as I say, in a very generic sense from the solvent, and it just comes from the environment, but it will allow itself to pick up a proton, and in doing so will then create the alcohol with the nucleophile that you've just reacted it with, and the CH3 drawn very badly there. So obviously the bond should correctly go to the carbon there. So now what we've gone is we've now moved from a trigonal planar aldehyde situation to a tetrahedral carbon center, and that movement from a planar structure in the carbonyl situation to a tetrahedral carbon here is then what gives rise to chirality, which we'll look at in the next couple of clips as we move on. But that's just a very generic reaction for nucleophilic addition, as I say, with any nucleophile reacting with an aldehyde. We'll look at a specific example in the next clip.